Great. So let's start, everybody. Hi, welcome to Linkin to your browser. I'm Alex, this is Catalin, and today we'll be talking about fuzzing HTML sanitizers. So first, a few words about us. We both work at Pentest Tools. I work on the DAS team. Catalin works on the exploit team. We are building a website scanner similar to Burp Suite and Aconetics, and Catalin works on building software that automatically exploits a vulnerability when it is found on a target. So what's today talk about? We will talk about fuzzing 15 HTML sanitizers across the most popular programming languages like Python, Go, Java, JavaScript, and Ruby. And we managed to find 3 vulnerabilities. The first one was in Python, in the LXML HTML clean library, which for reference was downloaded 3 million times last year, in the last month. The second vulnerability was in Ruby, in the third most popular library. It's called rgroove sanitize, and it was downloaded about 1.1K times in the last year, so much less. And the last vulnerability was in Go, in the most popular library there. It's called Blue Monday. We don't have any statistics for it, as package.go.dev doesn't provide any. We used these vulnerabilities to exploit 3 applications. These applications were Odoo, which is written in Python. This is a SaaS, which is used by about 5 million people. They offer software for all kinds of business processes like support, marketing, HR sales, internal communications, and others. The second was in Gitty, which is written in Go. It's a self-hosted alternative to GitHub and GitLab. They are used by Google, MasterCard, and OpenStack. And the last vulnerability was in Discourse, which is a platform for building forums for your application. They are used by OpenAI, Docker, and GitLab, among others. This is our table of contents for today. We'll start with the research context. We'll talk about when XSS is still a thing in 2024. Then we'll continue with how we set up all the backend sanitizers and the fuzzer that we use for this talk. Next, we'll switch it over to Catalin, who will talk about triaging the results that the fuzzer generated and how we went about finding open source applications that were actually exploitable. And we'll finish up with some open questions that can be used for future research sessions. So let's start. So when is XSS still a thing in 2024? XSS is mostly solved nowadays in modern web applications because you can use server-side or client-side frameworks that automatically escape user input when it's given to templates or components. Things are secure by default, and you really have to go out of your way to introduce an XSS. But there are certain classes of applications where you are expected to render user-supplied HTML. Some examples are email clients like Gmail or ProtonMail, messaging applications like Slack, Discord, and Microsoft Teams, and rich text editors like TinyMC or CK Editor. So if you're a developer and you are tasked with implementing such a feature, how would you go about it? You'd probably use an HTML sanitizer, and how they work is that you define a set of allow tags, optionally with some specific attributes that are allowed for each of those tags. You give it user input, and you get out clean, safe, XSS-free HTML. Now, Purify is probably the most well-known example, but its programming language comes with more such sanitizers. There's a lot of them. We took a look at 15 of them across 8 programming languages. We looked at Java, PHP, Go, C#, Ruby, Python, JavaScript. And how do you break a sanitizer? As with any other type of software, there's 2 ways. You can treat it like a black box. You fuzz it and see which of the outputs are unexpected. And the other way is to do a code review to find logic bugs in the implementation. Fuzzing might be fast in some cases, but you usually need a good fuzzer to find cool bugs, and writing a good fuzzer takes a lot of time. Code review was also not an option for us because we only had a few weeks for the whole research, and we didn't have time to go through 15 different code bases. So we decided to tackle an easier question than only look at one specific tag. We looked at A tags for this research because they are a curious edge case. They are universally allowed in the software that we previously mentioned, but even when they are allowed, they pose a danger to the JavaScript scheme. And we came up with two possible attack scenarios. The first one was to trick the sanitizer into allowing an URL with a JavaScript scheme. This is an example of an actual vulnerability that we found. If you insert a HT control character in the middle of this protocol name, you will get out an XSS payload. And the second option was to find the parcel differential between the browser and the sanitizer. The idea here is that for the same input, the sanitizer will see a tag with some attributes, and the browser will see a tag with another set of attributes. After we decided we wanted to do, we moved on with setting up the infrastructure. This had two parts, the sanitizer and the fuzzer. We'll start up with the sanitizer. Since we didn't want to write a fuzzer for each of the 8 languages, we decided to put each of them behind an HTTP server so we could send the payloads in a standardized way. This is an example of a simple app for Python. This is the bleach sanitizer. We are reading input from the query string, defining the A image and strong tags as being allowed, defining the href source and alt attributes as being allowed on all tags, and then we are returning the sanitized input in the response. Furthermore, we decided to Dockerize each of the sanitizers and put them all behind an nginx rebirth proxy. This allowed us to do two things. First, it was easy for both us and anyone to deploy them on their infrastructure. And the second advantage was that if you wanted to fuzz a sanitizer, it was just as easy as sending your request to sanitizer name to language name / sanitizer name. So for example, if you wanted to fuzz all the Go sanitizers, you'll send your request to /go /sanitizer name with the payload in the input. If you want to try it out yourself and fuzz some sanitizers, all the code shown in this talk is open source at this URL. You can add your new sanitizer, you just run the build script, and you can just start fuzzing. Now I'll do a small demo of the build script. Let me. Oh, you can't see my. For some reason, you can't see my terminal. No. So the demo gods are not with us today. Luckily, we have a backup video. Give me a second. Okay, so here we have our build script. What this does is that it will build all the images for all of the languages. And then you can run the core compose up, and all the sanitizer will be spin up. Oh, I had a more impressive demo because the script's been updated, but unfortunately that's all we have here. So the main idea here is that adding a new sanitizer either for a existing language or a new language is as simple as just creating a new Docker file, put it in a pre-existing container, and the script will automatically generate the Docker Compose file and all the setup that you need. With the backends out of the way, we turned our attention to the fuzzer. First, we tried to use a pre-existing fuzzer, but they were too complex and hard to adapt to our specific question. So we decided to write a small, simple one ourselves. And how it works is that you give it a fuzzing template, a target URL, and optionally a proxy like burp that can store requests, and you just sit back and wait. How do you define a fuzzing template? So a fuzzing template is three things. It's a payload, it's the position inside the payload where the fuzzer should insert characters, and the output that we expect to see in the response in case of success. This is a template. So here we are fuzzing the inside of the JavaScript string, and we expect to see the JavaScript alert string on a successful payload execution. The fuzzer also supports inserting into multiple positions, and it will go through all the possible combinations of characters in its internal character set. The default character set is the ASCII control characters, and what this means is that the number of payloads will grow exponentially with the number of fuzzing positions. If you fuzz 3 positions, you get 70,000 payloads. If you fuzz 4, you get almost 3 million. So fuzzing 14 sanitizers for 4 positions will probably take a lot of time. I was planning to do a demo of the fuzzer, but we'll go to the video again. Let's see if I can. Okay, so this is our fuzzer here. This is a template, a default template that comes with the repo. So we are fuzzing the JavaScript scheme in 3 positions, and again we are expecting to see the JavaScript alert string. Now we'll make a simple template just for this demo. And we'll fuzz just 1 position at the end of the and now we run our fuzzer against the LXML sanitizer in Python with the template we just wrote. And we'll fuzz the text query character. And what you can see here is that the fuzzer generated 41 payloads, and it found 2 possible matches. So we can see that in the case of the LXML sanitizer, the 1B and 1A characters are stripped out when the input is sanitized. But now I'll let Catalin tell you more about how we fuzzed the rest of the sanitizers and the vulnerabilities that we found.
Yeah, now we'll discuss about how we did the triage phase. Ia, dai tu, te rog. Nu reușesc. S-a bușit. Da, iar.
Dau slash-ul. Dau slash-ul. O să vezi acolo.
Nu pot să pui aici, pe partea asta? Că nu pot să dau...
Demo gods are not with us again.
Dai cu presenting. Tot așa cu notes, da, făcuți. Și...
Pe asta.
Nu se scot iar?
Nu știu. Sorry again.
Așa, alba.
Ce? Nu. Ca acum.
Mă trage pe aia în dreapta și dai full screen. Okay, sorry for that. We'll discuss about how we did the triage phase. So to do a triage, we had to filter a valid potential payload. And we did that by intercepting all the requests by using burp suit. And we've applied filters. So the filters helped us to check if the sequences like JavaScript double.alert were broken or not. That ensured us that the sanitizer didn't correctly sanitize the input. However, in the first phase, we got a lot of false positives, and that happened because the whole HTML necessary for it wasn't able to be executed. And as a solution for that, we've implemented a method in the fuzzing script. That method uses Selenium, and it allowed us to automatically trigger the XSS within the browser context. And now let's jump into the specific vulnerable libraries that we found. The first one is the lxml.html.clean written in Python. The problem with this library was that the clean function consumed the x1a and x1b characters and didn't correctly parse the Unicode chars. This means that it transfers sequences like Java S1b crypt to JavaScript. And the root cause for that was because the underlying libxml2 library, it kept the characters inside during sanitization, but it stripped them out when the input was serialized back to the string. The second one was Blue Monday, which is written in Go. Blue Monday uses custom policy to allow defined content and attributes. In Blue Monday, we have 3 different policies that you can define. The first one is the UGC policy. UGC policy allows by default some tags like age and div. The second one is new policy. New policy is an empty policy which doesn't allow any tags. And the third one is strict policy. It is in fact just new policy, but it just has another name. So to allow the href attribute in the A tag within the Blue Monday library, you can specify 2 functions called allow attributes and on elements. As we can see, you can define the new policy and just call the to function over the policy. So we would expect that Blue Monday to parse the href content by default. However, being defined as an empty policy, new policy doesn't parse the content of the href attribute. So we can easily inject some JavaScript code inside the href content attribute. And to avoid that, you should manually add an attribute, which is called allow standard URLs. Without this attribute, you have your policy vulnerable. The third library is Sanitize, which is written in Ruby. Sanitize lets you define allow content and tags by using fragments. You can just specify 2 parameters inside the fragment, like elements and attributes. And there you can go with your allowed tags and attributes. Similar to Blue Monday, Sanitize doesn't correctly sanitize the content of the href if the protocol's parameter is missing. So it means you have to manually add this parameter and specify inside it the protocols that you want to use for your href attribute. And now let's jump into our vulnerable software and how we found them. We know that manual searching through large repository can take a lot of time, so for that we need an efficient method to identify and extract repository that use patterns of sanitizer function calls. We'll take a look inside the new policy in Blue Monday, the html.clean lxml, and the sanitize fragment in AirGroove. For that, we used multiple search engines like SourceGraph, BigQuery, and GitHub API. Basically, all do the same thing. You can search for code patterns inside multiple repositories. However, every engine comes with a downside. Source graph may not index all the code. BigQuery has a cost for every query that you run, so it means that large queries can lead to big costs. And the GitHub API doesn't offer star sorting. And why do you need star sorting? That's because we want to extract the most relevant repositories. And a solution for that was to build our own script so that we can scrape the repositories from GitHub and sort them by the number of stars. Also, this search script is present in the repository we have mentioned before. You have to just add your GitHub API key, run the script with the code pattern that you want to search for. The results include only repositories with more than 500 stars stored in ascending order. We also have a short demo here about this running script and how this works. So we'll search for an application that uses the new policy in Blue Monday library. We can also specify the Go language. And as we can see, we have all the repositories that we search for. We have the number of stars associated, and also the file that contains the code pattern that we searched for. Okay, now let's discuss about specific software that we found. The first one is Odoo. Odoo uses the lxml.clean module to sanitize messages through its chat and support application, which is called Discuss. We found an unauthenticated XSS in Odoo, which can be chained with another vulnerability. This vulnerability was marked as a feature by the Odoo team. We'll present you a small demo about this vulnerability. So on the right side, we have a visitor on the website, which can send the payload. On the left side is the allow privileged user, which can answer to support chat and can see the message sent by the visitor. Now we'll send the XSS payload to the target. We'll intercept the request and insert inside the body parameter. After the request was sent, we can take a look inside the authenticated user that got the XSS payload. And when he clicks on it, we can take a look inside the browser console, and we can see that the remote script was fetched. And now, taking a look inside the Burp collaborator, we can see that we got some information from the Odoo database. The second software that we found is Gitty. The problem with Gitty was that its repository description was sanitized by using the Blue Monday's new policy. And that happened because the required parsable URLs attribute was skipped. We can see in the following image that the new policy was defined. Also, we can see that it allowed links and content like the href target URL for the A tag. And for the patch, the allow standard URLs attribute was added. With this XSS, we can trick any user who clicks on the repository description to have its account cookie stolen. And the third one is Discourse. The problem with Discourse was that its protocol parameters was missing. This means it didn't validate the scheme by default inside linkable tags. And this way, the form template feature was vulnerable to XSS. Also, we can see in the image that it didn't have any protocols parameter, and after the patch, it was added, specifying the protocols that you want to use. However, this form template was protected by the CCP, but the bug was fixed by the Discourse team. And now let's discuss about what can be done for future research. As we have seen before, most sanitizers specify which protocols are safe to link objects such as HTTP, HTTPS, or mail to. And the idea is that maybe we can trick the sanitizer to skip the protocol validation. For that, we can use the Postolache cheat sheet. Also, we've seen that this pattern is usually injectable in rich text editors, chat application, and customer support systems. We only looked for open source software, so you should keep an eye out for vulnerabilities in closed source software that has these types of feature. And the last one, you can use a proper fuzzer like Domato, which is written by Google Project Zero team. You can define more advanced grammars with Domato that can generate more complex samples. And this way you can identify vulnerabilities in the parsing logic because you can evaluate the edge cases. Thank you.
Thank you very much. You surprised me with the end. Do we have any questions? He was just wavering. I've seen him. Questions? Yes. Coming.
Did you guys obtain any CVs for these vulnerabilities?
For these three, just the Git got the CV. And also we've got two more, but we didn't present that in this presentation. One was related to also the LXML library, and the other one was just a misconfig in how the sanitizer happened inside the front-end application.
Yeah, I have a question too about the Odoo software. Did you get a CV for that or what?
For what software?
So for Odoo.
No, we reported that to their bug bounty program. That was about 6 months ago. They said we can present it, but they still didn't fix it. So.
All right. And so basically that means you can steal cookies from the administrator at this point.
You can do a lot of things. The second feature allowed you to run arbitrary queries around in the database.
Right. Okay. Thank you.
One in front.
What would you think would be the best approach when choosing a library when building an app with Python, for example, to avoid the vulnerabilities?
So the first thing that comes to mind is to choose something that is really battle tested. For example, in spite of the fact that for the clean library in LXML, they specifically said don't use this for sanitizing because bugs have been found historically and use another library. There was still a lot of open source applications that use it. So choose something that is battle tested, is maintained recently, and I think that's it. In Python, there is a gap now because Bleach has been abandoned in the past year, I think, but it's still the most used.
Thank you.
Hello. Thanks for the presentation. I have a question about the PHP implementation. So you've mentioned at some point that you did some tests on the PHP.
Yeah.
Can you share some light on the results, please?
We managed to find no vulnerable libraries with the templates that we used. We looked at 3 or 4 libraries. One was the built-in sanitizer in Symfony. Another one was something that's built in PHP, strip tags. And another one, which I think is the most used, was something like HTML sanitizer. That was the name.
Okay, so PHP is good in terms of, I mean,
yeah.
from what you've tested.
Yeah.
Okay, thank you.